Welcome to the SEI podcast series, a production of Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center operated by Carnegie Mellon University and sponsored by the U.S. Department of Defense. A copy of today's podcast will be available on the SEI website at www.sei.cmu.edu/podcast. My name is Suzanne Miller. I'm a principal researcher here at the SEI, and today I'm thrilled to introduce our director of the SEI, no other than Dr. Paul Nielsen.
Yeah, nice to see you, Suzanne.
And he's been our CEO since 2004,
yeah.
So has grown up with a lot of the things that have been happening in the defense acquisition system and the things that the SEI deals with.
Right.
So today we're here to talk about your involvement in the Defense Science Board that recently published a report in February's Valentine's Day report, February 14th of 2018, and talk about some particular topics in there. The two that you and I have spoken about are software factories and software is immortal, which is quite a quote.
Yes.
So before we get into that, would you give our audience that don't know you well a little bit of your background and how do you end up with all of this Air Force acquisition, Science Board kinds of activities?
Sure, I'd be happy to, Susie. Well, as you know, I started my career in the Air Force. I went to the Air Force Academy and then spent 32 years in the Air Force. But what's unusual for an Air Force person is I wasn't a pilot. I was always a research and development person. During the years I was in the Air Force, from 1972 to 2004, systems changed a lot.
True.
In 1972, systems didn't have a lot of software in them, but by 2004, they had lots of software in them. So I kind of watched this whole thing grow during my Air Force career. At one point in the early 80s, I was working on a satellite program, and we had software on board and software on the ground stations and stuff. But the software on board was considered a small component at the time.
Right.
By the end of my career, software often was the whole system. That's where the functionality was. And big airplanes, tanks, ships, most of the functionality in the systems is really being determined by software.
One quote I saw is that 80% of airframe software is functionality is derived from software.
That's what they say, yes. Yes.
So you can't land it without software, you can't take off without the software, and you can't navigate without the software. So we are software reliant.
That's true. And you know, I was trained as a physicist, not as a software engineer, because when I was going through school, they didn't have such a thing as software engineers. But I was always entranced by the computer science side of this. And so when I did my dissertation, it was a computational physics kind of project and stuff. And I was big into modeling and simulation at the time.
Which has come back again.
Yes.
So we'll have another conversation about that sometime, because that's a topic all unto itself. So the Defense Science Board looked at defense acquisition of intensive software-reliant systems most recently. You were part of that team, and there were several recommendations that are very interesting out of that. The first one is that we need to fundamentally adopt the concept of a software factory.
Right.
Now, you and I have both been involved in software long enough to know that there's the software factory ideas been around for a long time and had some connotations in the 80s. I'm not sure that we're talking about the same thing today. So
no, we're not. Thank
what are we
goodness.
talking about today and how is that different?
A good point, because when people first hear the word software factory, they think about that 1980s or maybe early 90s view, and that was more like a modern industrial factory, you know, with people almost in cubicles going chunk-a-chunk-a-chunk. And that's not what we mean by a software factory now. What we mean is really building the environment around the programmers to help them be more productive, to help them do their job creatively, because they're doing a very creative job when they build software, but do it with support systems that help manage the configuration control, that help maybe test stuff every day, that look for bugs and cybersecurity flaws. And now we have so much capacity in our computers that we can do this every day and test our software every day as it gets checked in. This allows people to be much more productive, and if there is a problem, you find out right away so you can learn from your problem, rather than the more traditional approach where maybe the major test wasn't done for 6 weeks, maybe even 6 months, at which time the nexus for the creation is kind of lost.
And I don't know about you, if you ask me, what did I write in a report 6 months ago?
Yeah.
That's kind of a little tough.
That's
if you ask me what I wrote yesterday,
yeah,
that's a lot easier. And I mean, a lot of what we're talking about in terms of the support that the software factory provides is exactly what you're saying, that support so we can do continuous almost feedback.
Yes.
And that feedback is not just from the test system or the configuration, but also allows us to actually get users involved, right?
Exactly. And as most people know, this is the way Silicon Valley companies, even those companies up in Seattle like Amazon and such follow, and they've done it to great effect. So this is one case where the military, where the government can learn from industry, sort of a spin into the government. The government has traditionally followed other approaches that were very requirements-based. And they've kind of perfected requirements engineering. But what we've found is that in many cases with software systems, we really don't know the requirements when we start, not completely. And they evolve with time as users start to experience the software. So another whole point of the software factory is to really enable continuous delivery, continuous integration, which allows users to interact with this much more frequently to figure out, is this going in the right direction? Do I have something that's usable now? Oh, what new feature would I like on top of that? So it's a much more intuitive and aggressive way to develop software.
Collaborative.
And collaborative, yes indeed.
Yeah. So this, any of our listeners probably that are in software development in Silicon Valley and other places probably recognize that we're talking about a lot of the principles that come out of the agile development sort of thing. And that is another piece of this, that the adoption of continuous iterative, may or may not use the word agile, but continuous iterative collaborative software development is really interleaved with this software factory idea. You're not looking at a command and control software factory, which is kind of what we were talking about in the 80s. This is meant to have that same basis of agile principles that drive why we're doing the feedback.
That is one of the unfortunate implications of the word factory sometimes. It sounds like we're trying to drive out the initiative and creativity when what we're really trying to do is enable the initiative and creativity of the programmers.
One of the things I used to tell people when I worked in process improvement consulting is we're not trying to make things that should be creative routine. We're trying to make the things that should be routine actually be routine. We don't want configuration management to have to be something you figure out every time you check in your code. We want that to be routine. We want you to be able to figure out the clever algorithms that are going to get the result that your customer wants. But we want these other routine things to actually be easy.
That's exactly right.
So, and 30 years after sort of the initial concept of the software factory, I think the tool chains that are in place now is really one of the enablers of this. And you can sort of take back, the tool chains are enabled by the processing power. The processing power is enabled by all of the innovation that a lot of which comes out of the defense industry. But all this goes back, but it's taken a long time to get to a point where we can actually do this.
Sure, and the other thing that's really happened is the general availability of cloud services. Allows us to build these tools in the cloud so that we can test them easily at nighttime with lots of computational power, lots of memory and such.
And so one of the things I noticed in the report, speaking of virtualization and cloud, is you do address some of the unique issues of cybersecurity because there are cloud environments that are a little too open for the Department of Defense. But we also have some concepts that have been very useful that have that we can take into the cloud. So the software factory idea is not negated just because we have to be in a secure environment.
That's right. The other thing for our listeners to remember is that in most cases, the Department of Defense doesn't develop its own software. We do have some places where real government people are writing software, and they do it very well. But most of this is being done by the defense industrial base, by the sort of major corporations that you kind of usually associate with the Defense Department, the Lockheed Martins and Boeings and Raytheons and companies like that. And so this is not something that the Department of Defense can do by itself. It's something that has to involve the whole defense industrial base as well.
And that's something that we are also then following to a certain extent the workforce development kinds of things that are going on in the defense industrial base, because commercial is educating software engineers. I mean, our education system now is educating software engineers in these techniques. So the DIB, Defense Industrial Base, is getting those engineers in. So exposing them to the waterfall processes after they've been taught agile processes.
It's not a good fit.
Not so
good.
Not
a good fit.
Yeah.
It doesn't excite them. It makes it hard to recruit them, frankly, because they know there's a better way to develop software, a more exciting way. I mean, I first learned to program 52 years ago. I know I look too young for that.
You do,
but 52 years ago, it was Fortran at the time. And in a sense, we kind of intuitively did an iterative design in those days. You know, because we'd build a little and make sure it worked. And then we'd build a little more and make sure it worked.
Because it took 4 hours to get it turned around.
That's right, that's right.
I mean, that's,
and so this is a return to our roots in some ways,
yes.
albeit with lots of great tools and technology around that to make you much more efficient.
And faster. I mean, the iterative process in the 70s was based on actually processing power restrictions.
Right.
It takes 4 hours to get your program back and your results back, right? So I can't afford for it to be wrong. Now we actually have this ability of almost continuous feedback from compile all the way through regression test.
Right, right.
So that's a big difference. So let's talk about the flip side of that. We can be very, very fast with our feedback for software that, and I love this phrase, software is immortal.
Yes.
And that's a recognition that I'm not sure even the commercial industry thinks about that much. That we tend not to say, okay, we're done with this piece of software, let's build a new one. We just continually evolve the software that we have, unless it becomes so brittle that we have to replace it. But if we think about it differently, that this software is going to be around forever, how does that change the way we think about sustainment, contracting, engineering, architecture? I think architecture is the big one in that sort of set of things.
To go back to my Air Force and DoD roots, there was a time when we formally would develop programs, and then we would have something called Program Management Responsibility Transfer, when we would hand it off to logistics and sustainment organizations. That kind of stopped, even for hardware-intensive programs, in the sort of 1990s, early mid-1990s, because we started to recognize that there was a more continuous life cycle development. So we went to a total life cycle development kind of process.
And integrated logistics.
That's right, integrated logistics.
Meant to be integrated into the development process.
But even then, in a hardware-type system, you know, there's a design phase, a build phase, and then maintenance. What happens in software is that software never stops evolving. I mean, even on your cell phone, you get those little notices that you have an update for your app, right?
Yeah,
all the time.
I pushed later just this morning.
or that operating system update comes, which takes a little longer to do. And so what we're seeing is that there's no good reason to consider the software to be in sustainment, because not only are you going to try to do those fixes, but you also want to take advantage of the flexibility of software to be updated and improved throughout its life.
Exactly.
We don't want the software in 2030 to be the software of 2020, right? We want the software in 2030 to be even better and to do more functionality. One of the great enablers of software-intensive systems is that these systems can evolve at software speed, not at hardware speed.
Oh, I like that.
So we can really keep these systems up to date and give users new capabilities on weekly, monthly, or whatever kind of term we think is right, a basis, as opposed to, you know, maybe a 10-year block change on a big airplane or a 20-year block change.
And we're looking at these methods and looking at this perspective for both sort of what I call traditional IT systems, the payroll system and some of our command and control, but also we're looking at it from the viewpoint of complex airframes and satellites and trying to look at how do we bring the lean engineering ideas into the hardware side also. Because if we think about this as an immortal software, I mean, B-52s are 70, I think.
They're getting pretty old,
years old. I mean, you know, we have some very old hardware.
Yeah, and they're going to be fine for a few more years, too.
We've done this. You know, we've proven that it's more or less immortal in hardware, too. So, so we've got to deal with those things. Now, those are things that are kind of related to our current systems in a lot of ways.
Yeah.
There's a new kind of system that we're starting to see deployed more and more frequently, and these are the systems that really take advantage of what we used to call AI, again in the 80s, but we call it machine learning now.
Right.
And the autonomous kinds of vehicles and systems that are operated where their learning actually evolves them.
Right.
And the basis for those, you know, you and I learned Fortran, and you know, so very procedural, and these are much more mathematically based, mathematical algorithms more than how did you code this procedurally, or even from an object-oriented viewpoint. How are we going to verify those systems? That's an old but new again question.
This is a very, very tough question, and it applies to learning systems that maybe stop learning after development, as well as learning systems that continue to learn after development. Yeah. Because one of the problems is that using these neural nets or deep learning kind of systems, we don't really know how a system's made its decisions ultimately. Right. We can test it and see what it does, but there's always that one odd test that it makes a different decision on, an edge case. Yeah. So we're going to have to come up with different ways to test and ways to continue to collect data even as systems are in the field. This is one reason why a lot of the self-driving car manufacturers are out there, not just designing inside their factory, but also operating stuff on the economy to collect data, to see what the real world does, okay? And it also involves sometimes a lot of modeling and simulation to build even more data in. Sometimes in defense systems, it's a little harder to collect data from the field.
Sure.
We don't have the millions of drivers that the automobile world has. We don't have the millions of users that an app would have. And when we do use systems, sometimes they're in very serious and potentially lethal consequences. Yeah. So we have to find some ways to have assurance that these systems are going to work the way they say they are, or the way we plan them to be, when we use them for the first time and when we use them afterwards. Now, in the case of a system that continues to learn, it's not the same system a week later than it was the week before. This kind of is not the way the Defense Department has traditionally done verification and validation, where they like to test a system of record and then release it to the field. These systems are going to continue to evolve as they go out in time. So I think what this portends is that for the IV&V community, for the, independent test community, as well as the development test community, they're going to have to work much closer together throughout the whole life cycle of the system. So the independent testers sometimes haven't been involved in the very front, and sometimes the development testers haven't been involved in the very back. But really, they're going to have to meld their interest and their procedures to collect the best data for everybody.
And this is, in some ways, I could argue that what you're saying is the idea of extending the software factory into more of test and operations, which gets us to another concept that the DSB report talked about, which is DevOps. This idea that we need to have a confluence of development and operational concerns all throughout the entire development and sustainment and operations life cycle. So all these things come together.
And of course, one of the big concepts that the DevOps movement brought in was the whole idea of a minimal viable product. And that's worked really well for the Silicon Valley companies, for the companies that are building on the internet infrastructure. And that can work really great in the IT systems. We have to find ways to take that into the embedded system world. Because in embedded systems, we don't always have the platform right away. But we can at least simulate the platform and develop capabilities in our simulated environment, even as the hardware is coming along as well.
And we're seeing much more interest in that. One of the pieces of work that we've been doing at the SEI for several years is model-based engineering. And the languages that support that, that's another area that we need to support better infrastructure. I'm seeing huge changes in the last couple of years in the interest in that technology. So there are things that the SEI in some ways has been the previewer of some of the things that are coming on now. We are also very involved in the DevOps world, in the Agile world. So we're actually in much of the space that this is talking about, sustainment, how do we acquire systems more differently? What do you see as sort of the key elements of the future of defense acquisition that we, the SEI, and that the community as a whole need to be watching for so that we can be ready?
So I'm really heartened by the response to this study and by some of the things I've seen since the study kind of concluded. Because when you go across DOD to the defense contractors as well as to the organic assets in DOD, you see people moving toward this approach. And there are islands that are doing this quite well inside the government already. I visited something at Schriever Air Force Base a few weeks ago showing a great DevOps approach to developing software for the National Space Defense Center. Up at Hanscom, I think there's a whole team that's working with Pivotal, a contractor, to train people in these kind of techniques to develop software for the Air Operations Centers and others like that. I know there's similar things in the Army and Navy, I'm just not as aware of them. But I can see this happening, and the thing that's great about it is the people that are going through this are excited because they can see the results of their work and see it working. You know, when you're on a program that takes 20 years to deliver, you don't see that. And people like to see the fruits of their labor and see that they work. So this is actually keeping people more excited about being in the defense industrial base, if the base can change a little bit like this.
And I'm seeing that in our work as well. I mean, it's very promising. People like to be able to be connected to their purpose.
Yes.
And, you know, people don't join the government workforce to, you know, become rich.
Nope, that's for sure.
They join, we can attest to that. But they join because of the purpose. They join because of the mission. And being able to see connection to that mission is one of the things that drives people to stay. And we need that talent to stay.
Oh, yeah. And it is a mix of workforce, too, because there's the organic side of the services as well as the defense industrial base. And they both have to be in harmony. One of the things that's a little hard right now is even though everybody wants to move toward this more agile approach, we still have processes in the government for oversight that are built for the previous way of doing business. And we have to learn how to adapt those best for this. When you do this, you give a lot of responsibility to the individual work team that's actually building the software. And it's not so much top down as bottoms up. And so we have to kind of adjust our systems to trust those work teams of the experts who know what they're doing, to listen to them when they say what their schedule is going to be and what their problems are, and to give them the creativity space to do what they do best.
And there's economic implications to all of this, as well as security implications. I mean, there's a lot that goes around this. If you were to say, you know, what's the one thing that if you're a program manager out in the DoD world right now, you should be really paying attention to that reflects what the DSB came out. What's the one thing that you would say?
I think you'd
pay attention to this.
Yeah, I think first off, you'd want to make sure that your contractor, whether you're just getting proposals in or actually on contract already, that they have an effective software factory environment, that they know what it is.
If they say, what is a software factory,
that's a problem.
That may be a problem.
Right, that they know what it is, and that they are taking advantage of all the kind of tools that are out there. These tools are evolving fast, too. So the tools that are the best tools of the day today won't be the best ones a year from now. That's how dynamic this whole situation is.
It is.
But it's a system where you want to stay in touch with all the commercial side of this software business too, because they're the ones pushing much of that.
Yes.
I think also I would really want to put more emphasis on the workforce and make sure that in my organic workforce, the government side, I have people who are at least savvy about this. They may not have to be the experts because they may not be writing the code, but they better understand the principles and the way to oversee and manage projects that are being done like this.
One of the examples you gave in the DSB report talked about one of the agencies that has adopted this very fully, that they have had to really bring up their game in terms of that's part of what makes it work, is that they have expertise locally on the government team, and that we're also seeing that where we see success in agile development is when the government actually knows how to interpret what they're seeing.
I think it does put a little bit bigger burden on the government to make sure it has technically competent people, and in the right numbers too. You know, and the government has some great people, but sometimes it hasn't had it in the numbers that they really need to cover all projects.
Yeah. So I want to thank you so much for having this conversation. I think it's important for our viewers and listeners to understand and go read this report. It's a good report.
Yeah, it's a good report. It's available.
It really is. It's publicly available, and the reference to it will be in the podcast transcript. So you can go get it. And I mean, there's great quotes in there, little stories. And I'm really pleased that the SEI was able, through you, to be a part of this work. Because
it was an honor to be a part of that.
It's you know, somebody said there's, you know, we've been doing these kind of reports for 50 years. This is the first report that the examples I saw show change in a very you know, significant way, and so I'm very heartened that we're kind of on a cusp of a new era, perhaps.
Well, when you work on one of these reports, you hope that people are heartened.
And that
not
really, depressed, right?
And that they really adopt some of these principles and that it makes an impact. And so I'm really glad to hear that, and I'm really happy to have spent some time with you.
Thank you so much. So for our viewers, this podcast is once again available on the SEI website at www.sei.cmu.edu/podcast. It's also available on iTunes. It's also available on the SEI's very own YouTube channel. And so I encourage you to go and get the transcript, get the resources, and take full advantage of this report. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you for viewing.